this segment, we will examine the use of the getX function, a method of the graphics.py library. We will do that through an assignment, an example, and actually we have seen most of that example in the previous segment. And the assignment says to create two circles, one in the center of the canvas, one at whatever spot the user may click the mouse. And the new part is the program has to move the second circle from whatever location happened to be to the right edge of the canvas and move that circle horizontally. As I said before, we have already addressed the first half of the problem at the previous segment titled Get Mouse. And below here is a sample program related to this solution. The remaining task to move the second circle to the right edge of the window remains to be solved. We know that the method move dx, dy moves an object along the axis x by the value of the dx argument and along the axis y by the value of the dy argument. We also know that if an object has to travel, let's say, a distance of 700 pixels and currently is at a position, let's say, of 625 pixels, then the object has to travel another 75 pixels. So we may say that the object has to move 700, which is the final destination. Again, the 75 pixels is calculated by the 700, which is the total length of what we have to travel, minus the position that we're standing now, that's 625. And if I subtract 625 from 700, that will give me the distance that the object has to travel. The problem, though, is that we do not know where our second object, the second circle, is standing along the axis x. However, we know that our second circle is standing, that point is contained in the variable, if you want, uLOC, then that variable is of type point, and we can see that on line 9. The method getX has been designed exactly for that purpose, in other words, to return, to deliver if you want. The getX will return the value of a point in relation to the axis x. The statement below will tell us where the object is standing in relation to the value of the number of pixels along the x-axis. In other words, the new log object stands somewhere and the getX method will return a number, and that number will be assigned to the variable, we named it xval, and that it will be where the object is standing here along the x-axis. And we're going to use, as we will see, that value to calculate how much we have to move horizontally in order to go from this current location to the 700. Now that we know where the object is located in relation to the axis x, we can compute the dx value, which indicates how much we have to move, how much we would like rather to move along the axis x. And that value of dx is dx 700, which is the end of the canvas, minus the location of where our object is sitting, in other words, xval in our example. And that, if we subtract the xval from the 700, the dx will contain now how much we have to travel, how much the object has to travel. The value of the dy, obviously it is 0 because the object, it will travel only horizontally and no travel along the y-axis, and that's why the dy is 0. Some pertinent information. If the dx is a positive number, the object moves towards the right, but if dx is a negative number, the object moves towards the left. Here is the Python code up to line 11, including line 11, we create the two circles. Line 17 is using the getX method to deliver the value of the point name new_LOC and deliver of that point the X resting place in a sense. In line 18, we subtract that from the 700, which is the size of the canvas, since we want to travel to the edge of the right part of the canvas. That will give us how much we have to travel. That will be the dx value. And then we're using the move method to move the object named circle y by dx number, 0. So we'll move as much as necessary to move the circle, the center of the circle rather, to the edge of the canvas. Here we see visually the results of our program. Lines up to 11 have created the top window with the two circles. Commands of lines 17 through 19 compute how much the circle has to move and move the circle accordingly. That is for now. Thank you.